transistor characteristics, CE characteristics. We can do CE, CB, CC characteristics in a single board. So here the transistor BC107, two power supplies, 0 to 5 volts, 0 to 10 volts, 4 different kinds of resistance, 1 kilo ohm, 2.2, 4.7 and 10 kilo ohm. This is input microammeter that can read up to 2000 microamps. This is input millivoltmeter. This also read up to 2000 millivolts or 2 volts. Output ammeter, we have given dual ammeter. So in this is a switch, we can change up to 2000 microamps or 200 milliamps by changing the switch. And voltmeter, it can read up to 20 volts, but our power supply is only 10 volts, we can read up to 10 volts. So right now I'm doing CE configuration from positive of the resistance power supply 1 to 1 resistance. I'm taking here 4.7 resistance. From 4.7 input ammeter positive, then from input ammeter negative to B, that is base. From base I'm connecting to voltmeter, input voltmeter. From input negative to power supply. So here we have done input connections by from negative into emitter. So right now I'm going with positive supply of the second power supply to 1 resistance. I'm taking 1 kilo ohm. Another 1 kilo ohm is given to positive of the ammeter. Positive negative of the ammeter is given to C. Voltmeter positive is given to the resistance N, and negative is given to the supply, and from negative of the supply to the emitter end. So we have done with the connection. So input output characteristics can be measured. So right now I'm doing input characteristics by placing input to some, say it is around 20 microamps. So here you can see IB is equal to 20 microamps. So IB is equal to 20 microamps. This is input voltage 0.5 or is 541 millivolts. By varying output, you have to note down these two readings. Only these two readings are important for the tabular form. By fixing the input, we are varying output. So for 0.10, note down the reading. So right now it is in microamps. If you want to shift it to milliamps, you can even shift it to milliamps. So here, so like that, 1 volt readings, 2.8 reading, 4.8 reading, 8 volts. Until 10 volts it is giving 0.2, this one. So if you go in microamps, you can make readings more. Say like this, 1 volt, because in microamps you can get more readings, like digital readings. So this is the reading for input characteristics, even noted as 1 volt, 2 volt, 3 volt, 5 volt until 10 volts. So again I'm giving 30, say suppose 40 microamps input. So 40 microamps, same steps, repeating 1 volt steps or is 0.5 steps. Noting the input and output. This is output ammeter, output voltmeter. So varying this I'm not doing. So you can see here the meter has been crossed. That is 2000 microamps. Current is more than 2000 microamps. So you can shift it to milliamps. So here you will be getting 2.8 milliamps. For 7.62 you are getting 2.8 milliamps. So you have to know how you have to note down the steps is 0.5, 0.25, 0.5, 1, 1.25, like that you have to go the steps, or else you can go for 1, 2, 3, 4 steps as well, volts. So input characteristic has been done. Now we are doing output characteristic by fixing the voltage here. So right now I'm fixing up to 2 volts. Say VC is 2 volts. Now varying input and noting these two readings. So for 200 millivolts, 0.2 microamps, 500, 4, 662. You can see the sweep reading increasing the microns after reaching 500 microns. 620, 100, like that you have to go. This is the readings for output. Similarly, repeat it for 4 volts. Again, changing these two. You have to note down these two: input voltmeter, input ammeter, by varying this power supply. For 100 millivolts, for 200 millivolts, 1 microamp. For 400 millivolts, 3 microns. For 600, 10 microns. For 650, 300 microns. For 7, you can see the raise in micron readings. For 700, 1700 microns. So this is the steps you have to follow and plot the graph between IB and IV. This is input current, input voltage, and also plot the graph between output current, output voltage. Thank you.